So question 2, there's 2 parts. So they draw this little diagram for us of what our classes and interfaces are. Question 2 will almost always be, actually always it will be like a question about classes. So you're probably gonna create your own class. So again, I'm gonna skip out on reading thoroughly. I'm just gonna look at the functions, what I got with me. So I got an interface for an item, has a purchase price method. Taxable item will implement item. Each taxable item will have its own tax rate, and we can see the constructor here. This is an abstract class. So remember we talked about it. We can have methods which are not implemented because we can't actually create an abstract class object. Okay. So I go through this and then I see finally purchase price is what needs to be implemented in part A. It says returns the price of the item including tax. Okay. Hopefully by now you guys already know how taxes work, but essentially you have a price and you have a tax rate. In British Columbia, I think it's like 15%. I'm not sure. 12, okay. And then so whatever the purchase price is, you multiply it by 1 point. In our case, it's 12%, so 12, and that's the actual amount you're paying. Okay. So we're gonna read into this question. It might be different, but generally speaking, if you know what taxes are, you kind of already know what you got to do. Okay. So let's actually look at what they want because they didn't give us too much information. They just said returns the price of the item, including tax. If we look through this, we see actually that the purchase price method is really just that. Okay, multiplying 1 plus the tax rate times the actual price. Okay, so part A should be fairly straightforward. We're going to do the method header, double purchase price. Okay. And really, we're just returning 1 plus the tax rate. Oh, I did an equal sign, sorry. 1 plus the tax rate times our price. What is our price? Well, it's saved in the get list price. Okay. Now this might be the confusing part, so let's just go up here. Get list price is the listed price of the item. Okay, it doesn't actually have code because it's an abstract class, but that's the idea of abstract classes. It's not implemented, but because we don't actually create a new taxable item object, it's okay to use this code because eventually we'll have code in it that will work. Okay, so that's part A. Fairly straightforward, yeah.
They're using this stuff, give this only like this.
Of course. Okay, you can also do this dot tax rate. Okay. Yeah, of course. And if it helps you make things clear,
Well, it depends where
either way is correct. If it's clear to you, if it's clearer to you to use this, I would opt to use that. This. Like on that change premise, if I write some sort of if statement, if I only have one line of code, I don't need brackets, right? Then you can ask me, should I use brackets or not? It's always better to use brackets, right? So in this case, yeah, go ahead, use this dot tax rate. Okay, if that, like, it is in a way more more clear to whoever's reading the code. The computer knows it's the same. Okay, awesome.
So if I use like even if it's only one line of code, I don't need brackets. It will still run.
Yeah, I believe it might also be true for loops and while loops, but I gotta look into that since I don't remember. I know in C++, for example, it works for loops as well. Yeah, you don't need brackets if it's only one line of code for if or else. Anyways, that's part A. Questions? Okay. So part B is really the class question. So we create a vehicle class. Really, I'm going to do it as I read it. So public class vehicle, okay, which extends taxable item, extends taxable item. And then what does it say? A vehicle has two parts to its list, to its list price, a dealer cost and a dealer markup. Okay, so I'm just going to create private double dealer cost, private double dealer markup. Cool. Yeah, the E here. All right, let's continue. The list price of the vehicle is the sum of the dealer cost and the dealer markup. Now, I remember from the taxable item that there is, remember, public double get list price. So I'm going to go ahead before I forget, because I just read it. Public double get list price. We're actually going to return okay, let's scroll back down here. So the list price is equal to the sum of the dealer cost and the dealer markup. So already I just read it. I'm just going to return dealer cost plus dealer markup. Okay, that's my list price. All right. Next, well, we got some examples. Your class should have a constructor. So we read the example, whatever, and then next. Your class should have a constructor that takes the dealer cost, dealer markup, and taxes the parameters. Well, already at this point, I could have figured that out, but now it clearly says it, right? So why could I figure out even up here? Well, because if I have parts of a complex data, I will need to probably get some information to save as those parts, right? So I would guess that if someone wants to create a new vehicle, they're going to save a dealer cost and a dealer markup. I'm a programmer, not a grammar teacher. Okay, so already over here, a vehicle has two parts to a list price, our dealer cost, dealer markup. Already over there, I could have assumed that I have the instance variables and a constructor that looks like this. Double cost, double markup. And then I just save dealer cost equals cost, and then dealer markup equals markup. Okay, now this isn't always the case, but I also know that in my abstract class, which I'm extending, there's a tax rate. So I could have assumed already that there is also going to be a tax rate. So double rate. Oh no. Okay, so here, and do comma, double rate. And because my constructor from the super class already takes care of it, I'm just going to send rate over there to be taken care of. Okay. So all three of these, this constructor, I could have already assumed it just based off the first sentence, but they're giving me this information again. Your class should have a constructor that takes dealer cost, markup, tax rate as parameters. Okay. Remember constructors. Oh, I forgot here, public vehicle. Okay. They don't have that return, that word of the return type, so we're not saying public void or public double. That's how we know a constructor. It just has the name of the class, okay? And it defines how we create a object of a class. Okay, so are we done yet? Well, let's read. Provide any private instance variable needed to implement all necessary methods. Done. Also provide a public method change markup. Okay, I haven't done that yet, so let's write that there. It changes the dealer markup to the value of its parameter. So public, we're changing internal data, so that's always void. They tell us it's supposed to be called change markup, and we're gonna be getting a new markup. Okay, the original markup was a double, the new one will also be a double. And then what are we actually supposed to do in here? Well, we're just changing the markup. We're allowed to do that. And that's all there is to this question. Okay? Any questions?
What is like the super?
How does super work? We talked about this a couple times, but just to quickly remind you. When there's several different ways we use the super, okay? When dealing with constructors, okay, if I put the word super as the first word, always has to be the first word in a constructor, it will take whatever input I put to the constructor of the superclass. Okay, so if I put this word here, the computer will scream at me. Okay,
Also have to be the first.
it has to be the first. Okay, another reason for the computer to scream at me is if I put either no input or more than one input or the wrong input, because what I'm actually doing is just sending information up to the constructor from the superclass. The constructor from the superclass only expects one input and it has to be double. Okay, so if one of the nice things about object-oriented programming is that we can kind of be lazy as programmers. We can reuse code. So if the constructor on top already decides to save tax rate, I don't need to re-save tax rate. I don't need to recreate a instance variable for the tax rate. The other superclass, this abstract class, already takes care of everything. I just need to use a super word, send the right information, takes care of everything. Let's give me the first word in there. Okay. There are more ways to use super keywords. Okay. So let's say I wanted to create a new class. I could do public get tax rate. Sorry, not new class, new method. Okay. This is going to get the tax rate for me. Well, tax rate, we don't have the instance variable here, right? If I had a tax rate, I would write like return this dot tax rate, right? But the tax rate is in the super, so I could do return super dot tax rate. Okay, and that will access the private instance variable. There are more uses to super. The big one they're going to test you on is this one here for the constructor. And maybe I'll send you guys some information about the super keyword for other uses, okay? All right, yeah, it's kind of like this keyword, just like instead of referring to this class, we're referring to the super class, okay? There's actually also, I believe, if I remember correctly, I could do something like this. Let's say I had another public vehicle, and this one just accepts markup, double markup. And then I did, oh, okay, and then I did double markup equals markup, right? I could do this. I could get rid of this line of code and do this markup. Right? Because it's gonna, the this and the super are very similar. This will say just take the constructor from this, and it knows to go here because there's only one input. That's what's type double. Okay?
Oh, it's always like here.
Yeah, because of the way I use it, right? But we also seen a lot of times that we use this dot. we could use this dot get list price, right? We talked about it, or this dot tax rate. So in that same way, we can use super dot get list price or super dot tax rate, right? So this and super are very similar. As far as the uses go and what you're going to be tested on, you're going to be using super mostly in the way we used it here. So, you know, if it's too much to handle, just remember super, we can use it to call a constructor from the super class. And then there's this keyword, we're probably not going to use it the way I just showed you. We're just going to do like this dot tax rate, this dot get this. Okay. Awesome. Any other questions?
Right. Super just refers to like the extend part, right? So contract extend.
In this context, yes, with this bracket and so on. But as I said, we can also use the dot notation to refer to specific functions or variable from the super class. Okay. Awesome. Okay, so again, I'm quickly just going to look at the functions and see I need to implement compare customer. We're dealing with customers. I see I can get their name and their ID. When I look at the compare customer, it says return 0 when the customer is equal, positive number if it's greater, negative number if it's less. So I got to understand what it means when a customer is equal or greater or less than the other customer. And that's going to be found over here. So essentially, what they're saying is if they got the same name, okay, they're equal. If they don't have the same name, then they're not equal. One is greater than the other, and we have to check, compare that through the ID. Okay. While we can figure it out here, I'd like to show you on part B. It makes a bit more sense. If we look at burden here, there's two burdens. One's 49.44. One's 39.11. Okay. 49.44 is greater than burden. So we got to return that this burden is greater than this burden. Okay. So if we go back up here and look at it once more, we say return 0 when this customer is equal to the other. Okay. Return 0 when this customer is equal to other. What does it mean when they are equal? Same name and same ID. Okay. So we really have to check two things. When they're not equal, we really just need to check one. Now, notice it's saying positive integer, negative integer. It's not saying exactly what integer we need. And then if we look down here, it tells us maybe consider using the compare to method from the quick reference sheet. Let's see actually the compare to method. Says here, returns a value less than 0 if this is less than the other, returns 0 if this is equal to other, returns a value greater than 0 if this is greater than the other. So really, it's almost the same thing as what we're asked to do. The only difference is that there's a situation here when we get the 0 if it's equal to the other. In that case, I have to compare the ID. Okay, so let's quickly write that up. Close this. Okay, so the name, public int, compare customer, and we're going to get a customer in there. Okay, so really the first thing I'm actually going to do is I'm going to compare both of them. So I'm gonna do, I'll do it the way you guys like. So this dot get name, okay, dot compare to other dot get name, okay. So I'm just gonna compare them, get the value, okay. If compare equals 0, what does it mean? The names are the same. So I'm just gonna return, in this case, according to the specifications of function, I'm going to return the difference between this dot ID minus other dot get ID. Get ID. Okay. And that really is key. Specification of positive integer when the customer when this customer is greater than the other. So it's this dot get ID is 2 and other dot get ID is 1. We will be returning a positive number. Okay. Now, what if the names are not equal? So if they're not equal, compare will not be 0, and I really can just return compare. Okay, and that's again because the specifications of the compare to function really equal the specifications of what we're supposed to implement part A. Questions? All right, let's move on to part B just because we don't have much time. Maybe I save your questions for after. Part B, the really complex part here is understanding what they actually want. Okay. What I like to do is use the visualizations. That's easier for me. For you, you might read through this and find it easier. Okay. What really they're saying, you're going to get 3 lists, list 1, list 2, and result. They're going to look like this. Okay, result is going to be probably smaller. If you read through it, it can be also equal to one of the lists. It's going to be empty. Okay, and then you got to put stuff from list 1, list 2 into result. They're telling you in a merge sort type of way. What does that mean? That's confusing. Let's just look at the example. I see the first input and result is Aaron. I look here. I see really Aaron is smaller than Arthur. So I'm going to put Aaron in here. Okay. Next, Arthur. Okay. Next, Baker. And then Burden. And then Burden. And then Dillard. Okay. Honestly, this can take 10, 15, 20 minutes just to understand. What you see after you go through this, after you go through all the readings, is that they're saying, compare the first element of each list. Smaller one, insert into the new list. In that list you took away from, right now, just move on to the next one. Okay? That's really all there is to it. So, to show you the code, we're going to do public static void prefix merge, and then just for the sake of time, we all know what the input should look like, so I'm going to call it L1, L2, and R. Okay, it's going to be an array of customers called list1, list2, and result. It says it on the next page, but I'm gonna not type it all out here. Okay, so if you notice, the sizes are pre-given, and what our end goal is to fill result. Okay, so we want to create a for loop which iterates through result and adds stuff to result. Okay, so we are gonna do r.length I plus 1. Okay. With that said, we also have to keep track of what index we're looking at in the previous list, okay? So I'm just going to call it int1 equals 0 and int2 equals 0 as well, okay? So 1 correlates to the index we're looking at for list 1, 2 correlates with index of list 2. Okay? And we're really going to just, first thing we do, for each pair of names, we compare them. So int compare equals L1 1 dot compare customers of L1 2. L2 2, sorry. Okay, so we're gonna use what we got previously. We're gonna get that result and compare. And then based on that compare, we said, well, the smaller one is the one that goes in first, right? So if compare is negative, right, the smaller one would be L1 of 1. So in that case, we are going to do result I. Well, let's call it Ri. Let's be consistent. Ri equals L1 of 1. If we do that, we're also going to increment 1 because we don't care about 1 anymore. Second option for compare. Else if compare is greater than 0, okay, well, we're just going to do the opposite. We're going to say that means L2 of 2 is greater, so we're going to say Ri equals L2 of 2. And obviously 2 plus. Last but not least, if they're equal, right, if we get back a 0, they're equal. It doesn't really matter. We could just do Ri can be equal to one of them. Let's just say L1 1, but it could also be L2 2. And then both 1 and 2 need to be incremented. And that's all there is to this method. So during an exam, this is another example where I could just read it and kind of write it. Okay, so really they're saying customers are copied into the results from the beginning of list 1, list 2, merging them in ascending order. Okay, so I could say, what does it mean ascending order? Well, what's bigger or greater? I got that information. So right away I make this int compare. And then I know I need to fill this up. So I know I'm doing a for loop, right? And because bigger or greater, I know I really got 3 options. So if, else if, and else. And I've got to figure out then the last part, what I do in each if, else, and else if. And to figure that out, again, for me, the example would be the best. So, questions?